Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome back to the next edition of our class online. This is SS3 chemistry class, and your host is Abdulatif Babalala, as you already know. We are looking at solution to the mock examination questions, and today we are looking at question 2. The aim of doing this is to equip you better for the external examination that you are preparing for, so that you correct all your mistakes here, and it will be an avenue for you to revise what you have learned in the past. Inshallah, immediately after the solution to these questions, we will look at some of the topics that you have learned in the past, one after the other, in order for you to relearn some of them. But today, we are looking at question 2 of your mock examination, as I have told you, and starting from question 2A1, you have to name 2 gases that can be used as bleaching agents. Name. Remember, when you are asked to name, write the name, not the formula. If you write the formula, you will lose the mark. You are asked to name, not to write the formula. Therefore, the gases that can be used as bleaching agents include chlorine and sulfur oxide. Of course, there's nothing wrong in putting the formula in brackets. SO2, Cl2. But first, it is the name that is required. Now, the next question. State the differences between the bleaching action of the gases named above. What are the differences between the bleaching actions? You remember, chlorine bleaches by oxidation, by oxidizing the dye, while sulfur oxide bleaches by reduction. That is, chlorine will give atomic oxygen to the dye, and the dye will become colorless. But sulfur oxide will withdraw atomic oxygen from the dye, so the dye becomes colorless. So chlorine bleaches by oxidation, sulfur oxide bleaches by reduction. Is a good point. Another good point is that the bleaching action of chlorine is relatively permanent, while the bleaching action of sulfur oxide is relatively temporary. Another way of saying that is that when chlorine bleaches, the bleaching is irreversible, but the bleaching action of sulfur oxide is reversible. So you are asked to state the differences. So once you mention either of the 2 differences, you are okay. Or you are asked to state the differences, so the 2 differences are required. 2A Roman figure 3. The examiner wants to represent the bleaching action of each of the gases in the equation. Now, I saw many funny answers here, but it is as simple as you have learned in your DSS and your SS2. For sulfur oxide, one thing you have to remember is that both of them bleach in the presence of water. Both of them require water for their bleaching action. So sulfur oxide will require water to form reversibly, to form trisulfuric 6 acid, gas, liquid, aqueous. Then the trisulfuric 4 acid rather, will react with dye, which is colored, to form tetraoxovic 6 acid. And dye will lose oxygen and become colorless. That is the bleaching action of sulfur 4 oxide. But as regards the bleaching action of chlorine, chlorine also bleaches in the presence of water. But in its own case, it bleaches by oxidation. Chlorine will dissolve the water. to form two acids, hydrochloric acid and the oxochlorate 1 acid. Oxochlorate 1 acid oxochlorate 1 acid will liberate oxygen atom. This oxygen atom is what is required to bleach the dye. So when oxygen atoms come into contact with the dye, which is colored, it becomes dye that has gained oxygen, and that is colorless. So these are the reactions involved. Bleaching action of sulfur oxide, bleaching action of chlorine. So easy. So easy. But you still have the majority of you missing the question. I'd like to understand. Question 2b1. You are required to define polymerization. Polymerization. Poly, from the word polymer. That is formula of formation of polymer. This is the process by which small organic molecules called monomer are linked together to form a giant molecule called polymer. Joining together or linking together of small organic molecule to form a giant molecule which is called polymer, is called polymerization. Now, there are two types of polymerization. The examiner wants to name them. What are the two types of polymerization that we have? Name the two types of polymerization. One is addition polymerization. Addition polymerization. Two is condensation polymerization. Condensation polymerization. So we have the addition polymerization and condensation polymerization. Many of you performed well in that question, and that is okay. The C part of the question, the examiner asks you to name two agricultural applications of radioactivity. This is a very simple question, but unfortunately many people missed it. The question is specific. Agricultural applications. The question does say state two applications of radioactivity. In that case, you would have mentioned any application you know, like radiocarbon dating, like sterilization, like determination of age of rocks, and so on like that. But here the question says agricultural. It means you are limited to agricultural application. If you go and study your notes, you would find that we have done justice to that. One agricultural application is it is used to induce mutation in order to improve the yield of crops and animals, to improve the yield of crops and animal by inducing mutation. So when you are when you are writing answer, it is better you also always read the question and the answer and determine how the answer corresponds to the question. Read it to yourself. Listen to yourself. So your answer must be of agricultural importance. That is one point. The other point is that it is used to control pests and diseases. When the pests are exposed to radiations, they are eliminated. So it is used to control pests on the farm. To question 2D. Question 2D. You have the following table shows the electronic configuration of elements Y and Z. Look at the electronic configuration. Electronic configuration of Y is as shown, 1s to 2s to 2p5. Electronic configuration of Z is as shown, 1s to 2s to 2p6, 3s2. Now you are asked to name the group to which Y belongs. Now in this case, you are not asked to name the element. Some of you went ahead and started naming the elements. When you have this type of question, nobody expects you to name the elements. Just answer the question that was given to you, except you are asked to name the elements. Name the group to which Y belongs. That's what concerns you. Look at Y. How do you determine the group? The determination of group of an element, when the electronic configuration is written in SPDF method. If the element is an S block element, the number of electrons in the outermost shell is the group. But if the element is P block, that is like this one, where P is the last orbital that is filled. To determine the group, take the number of electrons in the outermost shell and add 2. That will give you the group. So in this case, the number of electrons in the outermost shell is 5 plus 2. That gives us 7. So the element Y belongs to group 7. That's the answer. As simple as that. The question went further to say that state the period to which Z belongs. Z period to which Z belongs. How do you determine the period of an element when it is written in SPDF method? Just look at the electronic configuration and pick the highest coefficient. What is the highest coefficient here? It's not 3. So the period, this one belongs to period 3. So easy. So easy. Now, next question. What is the number of protons in Z? Number of protons in Z is the same thing as the atomic number, and that is number of electrons. Since it's a neutral atom, so just count 2 plus 2, that's 4, plus 6, 10, plus 2, 12. So the number of protons in Z is 12. 12. Number of protons in Z is 12. Next question. How many unpaired electrons are in an atom of Z? How many unpaired electrons are in an atom of Z? So looking at Z, how do you determine the number of unpaired electrons? Just look at the last orbital that is filled. What is the last orbital and the penultimate orbital? That is the orbital just before the last, the two of them. Now we have the 2p6 and we have 3s2. So the P block is made up of 3 subatomic 3 orbitals. And you have 6 electrons. 1, 2, 3, 4, 5, 6. One paired electron here. Then the next block is made up of 1 orbital. So and we have 2 electrons there. 1, 2. Both of them are, the electron there is paired. So there's no unpaired electron. So the number of electrons, the unpaired electron there is 0. 0. 0 unpaired electron. Now question number figure 4. Write the formula of the compound formed between Z and Y. To get the formula of our compound, look for the valencies of the combining elements. Z, the valency of Z is number of electrons in the atom shell because it is an S block element. So the valency of Z is 2. The valency of Y is the number of electrons, because even if it's a P block element, the number of electrons required to complete the orbital. Now this is a P orbital. So the P orbital takes maximum of 6 electrons. So it requires only one electron to be complete. So valency of Y is 1. So the formula will be ZY2. So this is from your SS1 lesson, chemical formulae of compounds. Next question. Question 2D and question 2E, Roman figure 1. Write the name and formula of a gas that can be collected by upward displacement of air. Upward displacement of air is the same thing as downward delivery. And for a gas to be collected by downward delivery, it must be denser than air. And if a gas should be denser than air, it means its relative density should be higher than that of air. Relative density of air is 14.42. Therefore, it means the molar mass of air, relative molar mass of air, is 28.84. We have calculated it using the idea that air is predominantly made up of nitrogen 79% by volume, oxygen 21% by volume. So using the molar mass of nitrogen times 79 plus molar mass of oxygen times 21 all divided by 100, we are going to get 28.84. So if the molar mass of any particular gas is more than 28.84, that gas is denser than air. Try that. And that gas will be collected by downward delivery or upward displacement of air. So you can work out, write the formula of any gas that comes to your mind, or as many gas that comes to your mind as possible. Determine their relative densities, or determine their molecular masses, and separate those ones that have molar masses higher than 28.84 from those that have molar masses less than 28.84. Those ones that have molar masses higher than 28.84 are denser than air. Those ones that their molar masses are less than 28.84 are less dense than air. Those ones that are denser than air can be collected by downward delivery, that is upward displacement of air, and those ones will fit into this answer. Those ones that are less dense than air can be collected by upward delivery, that is downward displacement of air. So I hope, I pray now you have to understanding of what we are saying. Just to answer the question, I can give you some examples of answers that can fit into it. I'll just give you two. By the time you do your own, you are going to get more. Chlorine gas, the name and the formula. Now you have to be sure of what you are doing. The question says name and formula. So I will give you one. Chlorine gas. Then you are now write the formula. That's where you full marks. So chlorine gas, then put the formula in brackets. Coming to question 2E, Roman figure 2. This question is calculation based. The examiner wants you to determine the volume of the residual gas when 20 cubic centimeter of hydrogen was sparked with 15 cubic centimeter of oxygen and the resulting mixture cooled to room temperature. This question has two parts, and you have to understand that. The first thing is to write the equation for the reaction. What are the reactants we have? We have hydrogen reacting with oxygen. Hydrogen plus oxygen, both are gases. And when they react, they will form water, which is gaseous form. According to Gay-Lussac's law of combining volumes, when gases react, they do so in volumes which are in simple whole number to one another and to the volume of the product. If gases, so the ratio of their number of moles is the same as ratio of their volumes. So as you have 2 moles of hydrogen to 1 mole of oxygen You also have 2 moles of water vapor. And that means that this is 2, if this is 2 centimeter cube, this will be 1 centimeter cube, and this will be 2 centimeter cube. If we now used 20 centimeter cube, as the question says we use 20 centimeter cube, what volume of oxygen will be needed? If you use 2 centimeter cube of hydrogen, you are going to need 1 cubic centimeter of oxygen. So if you need 20 centimeter cube of hydrogen, it means you are going to need what? 10 centimeter cube of oxygen. And that will produce 20 cubic centimeter of water vapor. But first of all, deal with hydrogen and oxygen. But the question says, even although we use 26 cubic centimeter of hydrogen, we were given 15 cubic centimeter of hydrogen or of oxygen. So the first thing that question is that, is there what volume of which of the is either of the gases in excess? The answer to that is yes. We had 15 cubic centimeter of oxygen, but we needed only 10 cubic centimeter. It means oxygen is in excess. So volume of excess oxygen is 15 centimeter cube minus 10 centimeter cube, which is equal to 5 centimeter. Does this represent our final answer? Let's consider that. So this is the volume of excess oxygen. But the product is also a gas. So we might be tempted to think that we need to calculate the volume of the products. Yes, that would have been the case, if not because of this last clause and the resulting mixture cool to room temperature. If the resulting mixture is cool to, because the mixture of what will remain will be oxygen and water vapor. But if you cool water vapor to what? To room temperature, it becomes water, and it will no longer be gas. But the question says calculate the volume of residual gas. So there are only 2 gases there initially, but when it is cooled to room temperature, it means only 1 gas. So the volume of water vapor is no longer required. So this will give us the final answer. So the volume of residual gas is actually 5 cubic centimeters. But if this clause is removed from the question, the volume of residual gas will be volume of oxygen minus volume of plus volume of water vapor. That would have been, this one would have been 20 cubic centimeter plus 5 cubic centimeter. That would have given us 25 cubic centimeter. But that is not required in this case. So our final answer in this case is 5 cubic centimeters. So I pray that Allah grant all of us better understanding, and I want to implore you to check your portal for the assignments and do the assignment as required. We are going to meet next class. Bye bye.